Hello, I am Asya.
Hello, I'm Kirill.
For the past 8 weeks, under the guidance of Thomas, my teammate and I have been working as Team Europe at Perseuss Internships. Today, we will present to you our code cartonization project, which is a solution to code shipping challenge.
Yeah,
Uh,
here's a little bit about us. My name is Kirill. I'm a student at Nazarbayev School at Kazakhstan, and I'm a robotics engineer.
I am Asya Ocak, and I am a student at Turkey, and I'm very interested in AI programming. So this is Ocak, a company that specializes in cold shipping, which is now exploring Perseuss. And in this internship, we've been working on a specific adjustment the customer has. They require a sub-problem of optimizing packaging for cooling gel packages alongside with the cold shipping products.
Yeah, so our goal was to pack pizzas and other frozen products with chill packs so they can save their temperature and preserve their freshness. Uh, yes.
So the problem is gel packs for cooling are not in a fixed number, and to put necessary amount of gel packs at each package, we need to know the number of boxes. But to know the number of boxes, we need to first distribute the pizzas. So in other words, the pizza count determines how many boxes we need, and the gel pack count depends on it. So this is like a chicken and egg problem. You can't decide the right number of gel packs without actually uh, splitting the pizzas across the boxes. So uh, we needed to make sure everything fits dimensionally, there's enough gel packs, and also the solution is effective.
Right. We had different iterations, but I would like to tell you about our first solution. We called it gel lid solution. And imagine a cup and a lid. We made it that way. We sent two requests. First was for our cup for our packaging for food, like our main frozen products. And second was for gel and for ice packs. And then we combined them. Uh, it did work. Unfortunately, we found out that there are some minuses in this solution. Firstly, it was disbalanced because our gel packs were distributed only on the top of the box, and we decided to change it. And also, there was a longer processing time, and we decided to stick to another solution a lot.
To overcome these cons, we did a final solution of a two-request algorithm. So our solution firstly packs the pizzas into boxes without no gel packs using an optimized algorithm of the Perseuss API. And then we repack each box with the necessary amount of gel packs added. And then this ensures consistent cooling and valid dimensions.
Yes, and to make sure that gel packs fit properly, we made a flexible fill rate for the box. You can see the formula below. It mostly depends on the volume of the box and the volume of gel packs.
So we dynamically change the fill rate in order to fit the gel packs in the designer solution. Here you can see the blue ones are gel packs, and then our pizza boxes are also stored alongside it.
Yeah, and on the right, you can see the example of request. Here, the customer can request the quantity, the dimensions, the volume, and the weight. And using this data, we can predict how to put these boxes into a bigger box, and it makes our solution universal, and it makes it comfortable to customer as he can use it for every box dimension and every product dimension.
So we use the already existing cartonization API similar to Team America, and then made some optimization for a more flexible and efficient packing system specific to gel packs. Our SWOT analysis are here when we determine the strengths, weaknesses, opportunities, and threats of the project. And then our strengths are supporting dynamic gel pack counts, easy to manage this and scale, dynamic volume optimization, and clean packing and cooling separation, which is essential for future updates.
Regarding our weaknesses, our system depends on accurate measurements, and if there's like measurements are not accurate, there could be some errors. And regarding our opportunities, we believe that our work made the gel distribution logic smarter and more efficient. And we also believe that it could be the adaptive solution for all products and all packaging dimensions. And our threats are like our threats risk are minimum, but shape and size logic may break. But as a each product has its weaknesses, so we'll discuss it later.
So why our solution is effective? It's a smart and scalable approach that balances efficiency, flexibility, and precision, which uses dynamic gel pack counts, and we check the real dimensions of each box, and the packing and cooling logic are clean and separate in case of separate processes. And then each business can change the rules and the box types. And then also we observe the fast processing 30 boxes under 30 seconds. So now it comes to demonstrate our product.
Yes, one moment. All right. We can demonstrate it here. So we already tested it on different type of requests. There were some big requests as like 30 boxes. We actually tested it, we didn't document it, but we also tested it with like 200 boxes, and it did work well. But unfortunately it takes time, so we will start with smaller requests. Yes, right now I asked our program to have 6 big boxes, 6 small boxes, and 2 gel packs. Let's see on the visualization. All right. You can see that in the first box we have 2 gel packs as we requested in the program to have 2 gel packs. And there are some boxes. Yes. Other boxes are in separate, I think, yeah, there are 2 boxes. Others are here. Yeah. So we also have 2 gel packs here. And we can try to use a different request. For example, okay, let's pick, I don't want to pick big one because it'll have a bigger, a longer time. And we already behind the schedule. Okay. Okay, for example, let's take this request as an example. This one is a bit different. It has 3 boxes. And you can see that there are 3 gel packs as we requested in this box. And in the other box, there are also 3 gel packs. They are red, you can see them. All right. Yes, I think we're finished with demonstration.
Okay. So it comes to takeaways, and I think I can start. Maybe. So while this internship, I learned like how collaboration works in real life programming, version controls and actually working with a team. And Thomas have been really helpful, like guiding us through this process. I think seeing how programming works in real life conditions, not just in coding projects, has really been invaluable to me for future projects that I will take part in.
Yeah, I would like to add, I really appreciate this hands-on experience. And I also really appreciate our work with Git and GitHub, because we are all international and in different countries, so we weren't able to like communicate freely. But GitHub makes our like version control really efficient. And I had my first Git crash, which I did. So sorry, guys. And I also wanted to thank Thomas and Milan and all of the Perseuss team to work for working with us, because it was really a valuable experience for all of us. Thank you so much.
So thank you for listening to us. And if any questions, we can answer them.
Thank you, guys. Amazing presentation. Don't feel bad about crashing Git, Kirill. I've done that multiple times. I've done that when I worked at Amazon, and yeah, my boss was not super happy. Anyways, any questions from the audience? So I have a question. It's gonna be a similar one to the first group. So you guys made a lot of progress, right? Like I've thrown a pretty hard problem at you, gave you kind of guidance, mainly let you sink or swim sort of a little bit, and you guys definitely pleasantly surprised me and exceeded the expectations. How, there's certain things where sometimes the boxes are not super full, or because it seems like you guys are trying to be adding a big buffer, just to make sure that everything fits. I'm curious, have you guys thought about extra logic, extra method that can let you reduce the fill rate a little bit more, and like increase the fill rate, like shrink the box sizes as you optimize?
All right, I think I can answer this one. So right now, as we showed you, our like fill rate adjusting algorithm works mainly with the box and with the gel volume. I believe that it can be optimized by like calculating not only the box volume, but also the volume of the products. And then we can extract from like the share of a product and then make it more efficient by using this volume.
Like we already dynamically changed the fill rate for like how many like we calculated how many spaces the JPEG takes, and we substituted from like the volume like we mentioned, but like Kirill said, by adjusting, maybe looking at possible places. If it doesn't fit, we can lower the fill rate, and then if it fits, we can place it like by playing with coordinates and the placements of the products. We could maybe make a more efficient logic.
Chris, I saw you ask a question in the chat. You wanna throw it at our interns?
Yeah, I was just curious, with this problem statement, basically. in the real world application, do we need to put the gel packs evenly distributed among the material to kind of keep that temperature stable and consistent? Or is it just important that the gel packs are included in the packaging to like add that extra mass so that, the temperature stays consistent?
I think it is important to distribute it evenly. When I was talking about our first solution where we had like a lid, I was really excited about this solution, like at the first glance. My logic was this way. Like cool air will go to the bottom of the box and everything will be cooled. But like in the real world, boxes are sometimes it can be like not on the bottom, they can be on the right side or on the left side. So I believe that even the distributing makes the solution more safe for the product.
Awesome. By the way, Chris is also an industry veteran, so thanks a lot. Thanks a lot for showing up today, Chris. Appreciate you. We have also Andrew Hayner of Medusa here. Thank you for joining. Also an industry veteran. It's actually Medusa has been the original customer. I mean, Perseuss would not exist without Andrew. So thank you, Andrew, for taking time hanging out with us today. You think we need the pallet solution at Medusa or the ice packing solution at Medusa?
Not yet.
Not yet. We're getting there. Well,
Okay, we'll tell Donish we have it.
right. Sounds great. Any other questions? All righty. So then, thank you for your presentation, Kirill, Asya.